Hello, everyone, and welcome to section 4.4 on factoring polynomials in Algebra 2. So this is a fantastic section. It's so important. You'll use this through every year of math. Being able to factor is going to be key for so much else that we do. So make sure that you really understand this section before you leave it. So there's three main steps for factoring. The first is to factor out anything that they have in common. So if you look down at number 1, all three terms, remember that a term is anything that is separated by a plus or a minus. So there's 3 terms here. This has 2 terms. This has 2 terms, 3 terms. Anything separated by a plus or a minus. Factors are things that are multiplied. Factors are things that are multiplied. So we're going to look for factors that they have in common. They all have an x. So my first step is to take out the x. And that leaves me with x squared minus 4x minus 5. That's called factoring out. And it's very easy to recheck if you remultiply it. X times x squared is x cubed. X times negative 4x is negative 4x squared, and x times negative 5 is negative 5x. So you can recheck it to make sure that you did it correctly. What I want you to do is take a minute and go all the way down to number 13 and see if you can factor out on any of them. Pause your video. Now, of course, you know I'm going to do it for you. So I'm going to show that factoring out step wherever I can. In number 2, I see that they both have a 3 and a y to the third. So I'm going to take that out. I'm left with a y squared and a 16. There's nothing to take out on number 8. 16 and 81 don't have anything in common, and they don't both have x's. On number 9, I see that I can take out a 3 and a p squared, which leaves me with a p to the 6. Be careful, not p to the 4th. P squared times p to the 6 is p to the 8th. Because remember, this means p times 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 p. It means 8 p's. So not p to the 4th, just a little note there. So p to the 6 plus 5p to the 3rd plus 6. On the next page, hopefully you found on number 3, 5z squared, which left you with z squared plus 6z plus 9. On number 4, you can take out an x, which leaves you with x squared minus 7x plus 10. On number 5, you can take out a 3 and an n to the 5th, which leaves us with n squared minus 25. On number 6, I can take out the 8 and 3 of the m's, because this one has m cubed and they all have more than that, which leaves me with m squared, pen trouble there, m squared minus 2m. And then on this one, I took everything out, but there's still a 1 there to hold the place. Be really careful of that. Think about this. If you had forgotten that and just wrote m squared minus 2m and said, oh, that's completely gone, then if you refoiled or redistributed, I should say, you wouldn't get back to the original. You need that 1 so that when you redistribute, you can get back to what you had before. So don't forget about that plus 1 right there. Okay? On number 10, you can't take out anything. They don't all have x's and they don't all have numbers. So we're going to have to leave it at that. Same thing with the number 11, nothing to take out there. Although I'm going to do something interesting. I personally think that it's always easier to factor if you make your first term positive. So I personally I think you'll find this easier, make first term positive by factoring out a negative 1. So if you take out the -1, you're left with 16 n to the 4th minus 625. I know it seems a little strange, but in the long run, it'll help you. I can't factor anything out of 12. And down here on number 7, I can't factor anything out. Ooh, but I can on 13. On 13, I can take out a 5 and a w squared, which leaves me with w to the 4th minus 5w squared plus 6. This is actually what I recommend you do on tests and quizzes. Factor out first. Eventually, it'll become a habit for you, and you'll factor out first because it'll make your life easier and better. But until you get to that point, just go through your whole test or quiz, factor out first, and then go back and factor. So I'm going to leave the factoring out first in red, and now I'm going to switch to blue. The second thing you should try and do is factor into 2 binomials. Now, it's really important that you leave the x there. That's still part of the factoring. Think about it this way. If you were to factor 20 into 2 and 10, and then you factored 10 into 2 and 5, but you left the 2 out, 2 times 5 doesn't make 20. You need to bring that 2 down. The answer is 2 times 2 times 5. You need all 3 of them. So to forget this 2 would be wrong. So you have to bring this x down as well. If you don't have that x, then it'll be wrong. So just make sure that you watch out for that. But if you still have an x squared at least, then you should continue to try to factor. So the way you should factor, I know we've gone over this before, but I'm just going to do a brief summary again, is it's reverse FOIL. So when you see x squared minus 4x minus 5, this is the first, this is the outer and the inner added together, and this is the last. So you need to find 2 firsts that multiply to make the first. So it's going to be x and x. And you need to find 2 lasts that's going to multiply together to make that -5. Well, luckily that only has one choice, so we know it's going to be 5 and 1. But the inners, 5x, and the outers, 1x, have to add up to make that inner term. So 5x and 1x only make -4x if the 5 is negative and the 1 is positive. So this is the operation that you're going to be doing. X minus 5 times x plus 1. Once all your x's are linear, that means to the first power, you know you can't factor anymore. Unless, of course, you didn't factor out in the beginning, then it's possible you could still factor out. But if you factored out as your first step, then you should be done. Try to factor further if you still have x squared or greater. So, like I said, not if they're all linear. This is assuming, of course, that you have factored out first. So, obviously, that's it. You've learned everything you need to know. You are more than welcome to turn this video off and try to do all of these on your own. But of course, I will do them with you now. So now I'm going to be doing step 2 on all of them. And I'll do step 3 at the same time. So moving over to number 8, we couldn't do step 1. This one doesn't have a red step. But I am going to try and factor into 2 binomials. So a binomial is 2 terms. So that means I'm looking for something plus or minus, something plus or minus. Now, when the inners and the outers cancel, that means that they add up to 0, which is great. It means that you know that they have to be the same in numeric value, but opposite in sign value. So the best thing to do is just to start with making them the same. Make this 4x squared and this 4x squared. Make this 9 and this 9. Making them the same means that when you do the inners and you get 36x squared, but you make this one negative, that'll give you negative 36x squared, and it does add up to 0. I'm just going to erase that. You can write them temporarily if you need to. Now, step 3 says try to factor them further. You only have to worry about step 3 if they're not all linear, and these aren't. See that x squared? So I'm going to try to factor it further. Sometimes you can and sometimes you can't. So in this case, again, there's no inner and outer. So I'm going to do what I did before. I'm going to break it down evenly so that my inners and my outers are the same. And now as long as one's plus and one's minus, I'll get that 0 that I need. So to make this one plus and to make this one minus, super easy. But be careful. The last times the last doesn't make the last. You need this to be a positive 9 and a negative 3, and a positive 3 won't make positive 9. So this is actually not factorable. I'm going to have to leave that one as 4x squared plus 9. But exactly what I just did will work for this one because this is a negative 9. So you have to really think about your FOIL. Always remultiply it out and make sure that it works. Okay, moving over to number 2 here. This is not linear. So I'm going to look for my blue step. Don't forget, watch out also here, to rewrite that 3y squared. The only way there's no inners and outers is if I make these the same but opposite signs. So one's a plus and one's a minus. Let's just check that using FOIL. So first, y times y is y squared. Outer, negative 4y. Inner, 4y. That gives me my 0y. And the last times last makes negative 16. So I'm feeling really good about this. That's my answer. I don't have a green step. I don't have to try to factor further because there is something that's not linear, the y cubed, but it's not a binomial. It doesn't have 2 parts. So I can go ahead and stop there. Okay, on my next one, back to my blue step, which is to try and make it binomials. Again, don't forget to bring this down. And now I'm going to make my binomial. Now this one's different than you're used to. It's a p to the 6. So I'm going to break it down into p to the 3rd times p to the 3rd. Remember that p to the 3rd times p to the 3rd is not p to the 9th. It's p to the 6 because this means p times p times p, and this one means p times p times p. And how do we write p times p times p times p times p times p? The exponential expression is p to the 6. So that's why it's not p to the 9th. So I can break this down into p to the 3rd times p to the 3rd. I do need to break down my 6. It's either 2 and 3 or 5 and or 6 and 1. I am going to go with the 2 and the 3 because that way when I add them together, 3p cubed, I'll get 5p cubed. If I had used 6 and 1, that also would make 5, but only if this one was positive and this was negative. That would also get you the 5p cubed, but it would give you a negative 6 on the end. So if this had been a negative 6, the whole answer would have been different. So I told you that if they were linear, then you could stop, but these are not linear. They're both p cubed. So I should see if I can break this down further. But I can't because it would have to be p squared and p. So my inners and my outers, which there's none of, would never cancel. Same thing with this one. So I am done. This is very much just a matter of practicing. So you're gonna wanna practice these. If you're still watching this video and haven't tried any on your own yet, I can't stress enough. I would stop this video and I would try this on your own. Number 3, I'm going to rewrite my 5z squared. I'm going to try factoring it into 2 binomials, reverse FOIL. I'm going to do z and z. I can choose 9 and 1, but you should always start with the factors that are closest together. So when you have 1, 9, 3, 3, start with the 3 and the 3. And sure enough, that makes 3z, and my outers are 3z. I'm doing reverse FOIL. So first, outer, inner, and then last, these do add up to 6z. So I know that I'm done. Now, it's very common not to write it in this format. I wouldn't box it yet. They're going to want you to write it as z plus 3, the quantity squared. Just like we would never write, oh, the answer is x times x. Nobody would write that. They would write x squared. Okay? Same concept. I don't need to see if anything can be factored further. My z squared is not part of a polynomial. It's just a monomial by itself. Number 4, I don't forget to bring down the x. I'm going to keep doing that. I'm not going to forget to bring down the 3 and the 5th. I'm not going to forget to bring down my 8m cubed. Okay. Can you tell that a lot of people forget this? Not you. You're not going to forget. And then I start my 2 binomials. I'm doing reverse FOIL, so the first times the first makes the first. The last times the last makes the last. So my choices are 1 and 10 or 2 and 5. Hopefully you're already seeing that you want your inners and your outers to add up to that. So I am going to choose 2 and 5. If this had been an 11, I would prefer 1 and 10. And if I make them both negative, then my inners are negative 2x and my outers are negative 5x, which does make my negative 7x. Now everything is linear, so I can go ahead and box my answer. Number 5 has no middle term, which means the inners and the outers canceled, which is great. It's a huge clue that it's going to be a plus 5 and a minus 5. So the last times the last makes the 25, and the inners and the outers add up to 0. My first times my first work. So again, reverse FOIL on that. Hopefully you're getting the hang of this. So on number 6, we've already factored out the 8m cubed. We're going to do the next step, which is factoring it into 2 binomials. So I'm going to break it to m and m, and this is lovely. It has to be 1 and 1. Those are the only things that multiply to make 1. So that the inners gives us 1m and the outers give us 1m. So we need a negative 2m, and we can get that if we make them both negative. Making them both negative still keeps the plus 1 as the last times the last makes the last. But remember, our final step is going to be to write that as 8m cubed times m minus 1, the quantity squared. That's how you pronounce that. M minus 1, the quantity, is being squared. Now, number 7 and number 12 are a little bit different. They have 4 terms. You're going to like 4 terms. Put a big smiley face by there. Do not be intimidated by 4 terms. 4 terms just means the inners and the outers were not added. That's all that means. Okay, but you can still do it. So you're still going to do the first times the first makes the first. So it's got to be z squared and z. And then the last times the last is going to make the last. Now you do have some choices for 20. It could be 1 and 20. It can be 2 and 10. It can be 4 and 5. But here's what's great. The inners and the outers have to make these 2 terms. Well, it's like working backwards. It's a puzzle. So if you need one of the terms to have a z squared, that term has to be with the 5. So z squared times 5. It's got to be 5. Well, if that's a 5, then I must be using this, which means the other half must be a 4, which is perfect because 4 times z is what you want. Actually, negative 4, which is even better because negative 4 times 5 makes negative 20. So that 5 is going to be positive. So don't be intimidated by 4 terms. Be happy. There's less guessing and checking and more just making it fit. Now, we haven't had to do this in a while, but we are going to do that step 3. we do still have a z squared in our problem. So I am going to try and factor further. It may not work, but I'm going to try. The z plus 5, not so much, but don't forget to rewrite it. And then the only way to break this down would be if the inners and the outers canceled, which they can if you make it z plus 2 and z minus 2. Then the inners and the outers cancel. So first, outer, inner, and then the last times the last makes your -4. So if you didn't do it yet, you should try number 12 on your own. It's also got 4 terms. But of course, I'm going to do it for you. So we weren't able to factor out on this one, so we jump to the step where you have the binomials. But again, the first times the first makes the first. Now this one's a little harder because you know it's going to be a y squared and a y, but it's also going to be a 3 and a 1, and you don't know which one the 3 goes with. And then you have your last times your last, making that 3. So I need to put a 3 and a 1 there, but again, I don't know what order. But here's the awesome part. I need a 9y and I need a y squared. The y squared can't have a number. That's perfect. If the y squared can't have a number, then this doesn't have a number, and this doesn't have a number. I say doesn't have a number, just the number 1, because that would make 1y squared. But if this is a 1, then by default, this one has to be the 3, because the last times the last has to make the last. And that also works that if this is the y squared and we're trying to make 3y squared, this must also be the 3, and that would make the 9y. So like I said, it's kind of like a big puzzle that you're trying to put together. And I hope that you'll practice it and get the hang of it, because factoring will help you so much. Being good at factoring, I should say, will help you so much. Now I do still have a y squared. So I think to myself, can I factor this further? So I know that I can't, because the inners and the outers would have to cancel, which would mean these two would have to be the same, and I can't break down 3. It's not a perfect square, so I can't break it down, and it's not a minus. It's lose-lose. It's definitely not getting broken down. Now this is the correct answer. I'm only going to rewrite it just to make it look neater. There's nothing wrong with that answer. Y squared plus 3 is just kind of colorful and it's got marks on it, times 3y plus 1. Okay. Number 13. So we already factored out the 5w squared. So we're on the step where we're factoring it into 2 binomials. Now, don't be intimidated by the w to the 4th. We're just going to break it down evenly, w squared and w squared. And you might think, well, how did you know that when you had a y cubed you weren't breaking it down evenly? Well, you can't, so I broke it into y squared and y. But y to the 4th, or w to the 4th, could be w to the 3rd and w, but I don't have 4 terms. They were able to be added together, so they must have both been w squares. Again, I'm trying to figure out, do I want the 2 and the 3, or do I want the 6 and the 1? Well, I do have a 5, and 6 minus 1 would make 5, but I need them either to both be positive or both be negative. So I am going to go with the 2 and the 3, and I'm going to make them both negative in order to make a positive 6 on the end. So first times the first makes the first, last times the last makes the last, and my inners and my outers add up to that negative 5w squared. Now, they're not linear. I still have a w squared, so you should be asking yourself, can I break that down further? But the 2 is not a perfect square, so I can't break it down evenly and make my inners and my outers cancel. Same with the 3. So I am done at this stage. So that's our last example of factoring, but you have plenty of homework to practice it on. And again, this skill is huge. So I want to make sure you recognize how relating the factored form of a function can help you understand its graph. Remember that factoring is what we do to find x-intercepts or zeros, okay? So x-intercepts and zeros. So match each graph with the related cubic polynomial. Use what you know about x-intercepts and zeros. Also, if it is a factor of the graph, it will bounce off the x-axis. So we'll talk about that when we get to one. But if I make this, remember this is y. So if y is equal to 0, what would make this equal to 0? Well, this would be 0 if y is equal to 0 if x is equal to 0, or if x is equal to 1, or if x is equal to 2. So can we find a graph that has 3 x-intercepts or 3 zeros? One at 0, 1, and 2. So I'm going to go onto a different page because I want to be able to see it's a little smaller, but I wanted to be able to see all of that at once. So I look, and remember the zeros, the x-intercepts are 0 would make it 0, 1 would make it 0, -2 would make it 0. So 0, 0. Okay, here's one that goes through 0, 0. Oh, that's the only one. So that's perfect. And it goes through 1, 0 and -2. So this is definitely F. Or maybe you're going to say this is definitely A, whichever way you say it. Now on B, this is what that note was trying to say about, oops, I just realized I copied that wrong. There we go. It says, if the factor is repeated, the graph will bounce. Really important. So a bounce is something like this. See how it bounces right there? It bounces at x is equal to 1. So this produces a bounce, and this one has a bounce. This one has a bounce at x is equal to 1. Because if x is equal to 1, that would make y equal to 0. If x is 1, think about that. You'd have 1 minus 1, which would be 0. This would be 3, right? 1 plus 2 would be 3. But at 1, this whole thing would be 0. So 1 creates a y value of 0. But it happens twice. Technically, I could write this out twice. So since it's listed twice, it creates what we call a bounce. And then this one also has a 0 at -2. So this one has a bounce at 1, so it's C. And it has an x-intercept at -2. So C, or you can label this one B, however you're doing it. All right, let's see. This one has another bounce. So I figure it has to be this one, but let's just check. When x is 1, that would make the y 0. We're looking for what would make this 0. And if x is -2, that would make the y coordinate 0. So this one is E. Now, if you think you have the hang of this, by all means, you can go ahead and finish it, but I am going to talk it through. Letter C would be equal to 0 if x was 1. That would make a 0. Because if just this one factor is 0, 0 times anything, right, no matter what those came out to be, the whole thing would be 0. So if x is 1, that creates a 0. If x is -2, that creates a 0. And if x is -1, that makes a 0. So I'm going to try and find that graph. And let's see. Oop, it's right here. -2, -1, and 1. So A and C if you're doing it that way. Letter D. 1 would make a 0. -2 would make a 0. +2 would make a 0. And that one is going to be B. Is that right? -2, oh no, that's a 3. Tried to do it too fast in my head. Let's see. We already have B. Negatives, here we go. -2, 0, and 2. So D. Oh, and D, they match. So by default, this one has to be F, but let's quick check. 1, 0, because you could have done one wrong like I just did. Or 3, 0. So -2, 1, and 3. Yep, that totally checks. Okay, so I would love for you to try a set of these on your own. Pause the video, see if you can figure it out. What is the difference? The difference is that you have to do the factoring yourself. These were already factored. That's what makes this step a little bit harder. So go ahead and factor and then see if you can match it to the correct graph. Of course, I will do it for you. So this one in factored form would be x plus 4 times x plus 1. I know that 4 can be broken down into 1 and 4 and 2 and 2, and I definitely told you to try 2 and 2 first, but that won't give you the inners and outers you need. So this would have zeros at -4 and at -1, and it's just a parabola. It's an x squared. So right away, there's actually only one parabola on here, so it should be this one, but double check. -4 and -1, so we feel good about that. Letter B, I can't factor out. It has 4 terms, but I'm not going to let that make me nervous. Instead, I'm just going to do the first times the first makes the first. Now, I know the last times the last is going to make 2, so it's got to be 2 and 1. But specifically, I need there to be a 2 with the x squared, so I know the 2 goes there. That's why I like 4 so much. And I know I need a -1 in front of the x, so I'm going to put the -1 there. And this needs to be a -2 to make the last work and to make my outers work. So at first, you might think, well, I can't tell what the zeros are because that's still squared. Right, that's the purpose of continuing factoring. Then this becomes x plus 1, x minus 1. And now my zeros are -1 would make that 0, 1 would make this 0, and 2 would make this 0. So which graph has zeros there? First of all, it's cubic. So I'm looking at this one, and this one. And I'm looking for these zeros. -1, 1, and 2. I think that would be this one. So F. Okay, let's do another one. Just erase those. Okay. This one, ooh, don't forget to factor out first. I can take out that x squared plus x minus 2. So what does that mean in terms of zeros? In terms of zeros, it means that if x is 0, not plus or minus anything, just if x is 0, then 0 times 2 times -1, you'll just get 0 all the way across. Or if x is -2, that would make a 0. Or if x is 1. Okay, do you see how that x affects it? It means that if x is 0, the whole thing will be 0. So I need a cubic equation. We've already used f, but actually we've used c, and now I have 2 cubic ones left. This one goes through 0, and this one goes through 0. But this one, -2, it doesn't go through -2. This one goes through -2, 0, and 1. So this one is E. All right, we're getting there. Another chance to factor out. And it's our last cubic, so I'm pretty confident that it's going to be A. But, of course, we're going to go ahead and factor it. Oops, that's a minus. And so my 3 zeros are 0 would make the whole thing 0. If x was -1, that would make the whole thing 0, or if x was 1. And that's this one right here, -1, 0, and 1. So A. All right, if you still have not paused this video, you should really try and do one on your own. On this one, I can break it down into x squared minus 4 and x squared minus 1. I'm not going to go through the whole factoring. You got to work on that on your own. And then that would give me x plus 2, x minus 2, x plus 1, x minus 1. So I'm looking for zeros at -2, at 2, at -1, and at 1. And I'm looking for a quartic equation. And if you really want to know, a quartic equation that has a y-intercept of 4. So there's a lot of information you can see. So I have two quartic ones, and this one has a y-intercept of 4. And it goes through -2, -1, 1, and 2. This is definitely D. So obviously, by default, the last one is B, but we will do it real quick just to make sure. I factor out the x, which gives me x cubed minus 2x squared minus x plus 2. I have 4 terms, which I love because it's a little more obvious what the answer is. I know that this is 2 and 1, but I know the 2 needs to go with the x squared for my outer, and it needs to be negative. And then this one has to be a -1. So that's how I can make it all work out. This can be factored even more into x times x plus 1, x minus 1, and x minus 2. So the zeros are, now watch this, I'm not going to put them as ordered pairs this time. -1, 1, and 2. And that's okay too. So I did think that it was B. Let's double check. 0 is there, -1 is there, 1 is there, and 2 is there. So it is B. All right. On the outside chance you had done this a different way, your answers, like if you matched the graph to the equation instead, then maybe you did this for your answer, which is fine too if you were just skipping ahead. All right, this is a little bit tricky. This is a formula. You are going to want to write it on your appendix somewhere to make sure that you have it for the future. Almost nobody memorizes this formula. It's how you factor the sum or difference of two cubes. So if you look at the first example, this is a cubed plus 3 cubed. If you can rewrite something like this, then you can use this formula. So the way you factor it then is, well, in this case, A is just A, but this is kind of like saying B is 3. So A cubed plus B cubed, A cubed plus 3 cubed. So B is 3. And then you literally just follow the formula. You don't even have to worry about the pluses and minuses. They're filled in for you. There's no pluses or minuses for you to think about. You just follow the formula. So I'm literally going to do A plus B plus 3 times A squared minus A times B, which would be minus 3A, plus B squared plus 9, which is B squared. That's it. Done. But you can only do it if you know the formula. So let's do another one like that. Let's do number 2. So I don't know if you recognize it, but this is 5x cubed. And this is 6 cubed. That's what you have to be able to do. You have to be able to find this. So let's just call this A. A is 5x. And B is 6. Some kids are much more successful when they actually label it A and B because that's how the formula is labeled. Now I do want to use this formula because this one has the minus and this has the minus. So now I know I need to use the second formula. And I'm literally just going to plug it in. A minus B. A minus B. That's simple. A squared. All right. This is where you have to watch out. Watch out for A squared. If you write 5x squared, it'll be wrong. It's A, all of A being squared. So I'm taking all of 5x and squaring it, which is 25x squared. that make sense? Whatever a is, make sure you square all of a. So if a is 5x, you want to square all of 5x. So 25x squared. And then I'm going to multiply a times b. So here's a and here's b. So 5x times 6 is 30x. And then I'm going to do b squared. B is 6, and 6 squared is 36. Here's a cool thing. You never have to worry about factoring that further. Sometimes you might look at it and say, "Ooh, does something come out of there? Or can I keep going with that somehow?" But you won't ever, ever have to worry about that, which is a really great thing. What you do have to worry about is that you still need to factor out first. That's why I call it factor out first. Even in these, you should still do that. So I can take a 2 and an s squared out of both of these. That leaves me with 8s to the third minus 27. I see a cube minus something else, and so I try to figure out if it's going to meet this formula. And sure enough, this is 2s cubed. 2s cubed. If I cubed 2s, I would get 8s cubed. And then 27 is 3 cubed. Therefore, a is 2s and b is 3. You have to figure out what this is the answer to when you cube something. That's going to be your a. So now that I know what a and b are, I can keep going. 2s squared, don't forget to rewrite that. And then I'm going to do a minus b, 2s minus 3. And now I'm going to do a squared. Remember, all of a squared is going to be 4s squared. A squared means 2s squared. But you don't want more parentheses in there, so actually write it out as 4s squared. And then next comes a plus b, a times b with a plus. So 2s times 3 is 6s. And the last one is b squared, which in this case is 9. 3 squared is 9. Pretty tricky, I know. You do have one more to practice on your own. If you haven't tried any on your own yet, you should do this next one. Okay, factor out first. And I personally would make the first term positive. I think factoring is easier when the first term is positive. So I would take out the negative, the 6, and the z cubed. I would take all of that out. And when you do that, you're left with z cubed minus, because I took out the minus, so minus times a minus would make a plus, 125. Negative 6 times negative 125 is 750. So that is a perfect cubed. So my a is z. I know that sounds weird, but the cube root of this is z, and the cube root of this is 5. So now this is the hardest part. This is the key. If you can get your a and b, then you just plug it into the formula. So here's the formula. Way up here, I'm looking up here. A minus b. A minus b. A squared. Z squared. A times b. 5 times z. B squared. 5 squared is 25. And just like that, you did it. So factor out first. Identify your a and your b. And then use the formula. Those are the steps. Okay, this last section is actually really cool. Really cool. So in 4.3, we learned synthetic division. So what's really neat is how synthetic division combines with factoring. So I'm going to take this and I'm going to do division. So I'm going to take the coefficient of 1 and then the 2 and then the -4. And then I don't know if you remember, but I actually have to put a +2 in there. +2 because I'm determining if this is a factor. I want to know if it's divisible. Well, if something is a factor, then there's no remainder, right? When somebody says, is 6 a factor of 24? It is, because there's no remainder. Is 6 a factor of 25? No, because there's a remainder. Okay, so this is a factor. This is not a factor. So how can we tell if something's a factor? If there's a remainder. This is where the remainder goes from section 4.3. So I'm going to quick do the synthetic division. Bring down the 1, add, multiply, add, multiply, add, and there's a remainder. So is x minus 2 a factor? No, because there's a remainder. Because there is a remainder. That's how you know. Determine, you should try these next two on your own. Determine if x plus 5 is a factor. I love these. You just have to remember to make that opposite. So if x minus 5 is a factor, I'm going to put this here, 3, 15, -1, careful, 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 0, and then 25, because there's no x term. So add, multiply, add, multiply, add, multiply, add, multiply, add. So yes, if this was a factor, then the remainder should come out to be 0. But that's not even the cool part. Are you so ready for this? Okay, now watch this. This is my absolute favorite. I know you think I'm dorky because I'm getting all excited, but this is really cool. Not only is x plus 5 a factor, but the other factor, you might think, okay, well, it's a factor, but I still can't factor it. Yeah, you can. The other factor is right here. 3x cubed plus 0x squared, so I'm not going to write it, minus x plus 5. I'm just going to put a little 0x squared in there. That is how you factor. Now, they only asked you to do this, but I just want you to understand that not only can you find out if something is a factor, you can actually factor it. And that's what we're going to do on the next one. Use the fact that x plus 3 is a factor, so it's definitely going to come out to be 0, to factor f of x completely. You have to be loving this. This is so great. So I do 1, 3, there's no x squared, careful, 0, -1, -3. So add, multiply, add, multiply, add, multiply, add, multiply, add. So it worked. Yes. X plus 3 is a factor. So cool. But even cooler is that x plus 3 is a factor, and the other factor is x cubed plus 0x squared plus 0x minus 1. If you're wondering how I know where to start, if it's x to the 4th, then after you do this division, you're going to be down to x cubed. Think about it, because x times x, if you were to remultiply it out, x times x to the 3rd would give you x to the 4th. So you drop this down a power. Now, of course, nobody would actually write that, so we're going to write it without. Sorry. We're almost done, pen. Pen's dying on me. X to the 3rd minus 1, because you wouldn't write it with the zeros in there. If you box this answer, you were a little too quick. Whenever you see an x cubed, you have to ask yourself if you have one of these special situations, and we do. So Oh, it just says down here. Okay, so my A is just X and my B is just 1. Remember, don't worry about that negative. The formula builds in the signs for you, which is lovely. So A minus B, and I'm using, you can't see the formula, maybe you wrote it on your appendix somewhere, but it's not on this page anymore. And then A squared, and then you do A times B, and then B squared. This is your final answer. So they gave you one factor, and you were able to use that in synthetic to get the next part, and then you were able to use your factoring formula to get the next part. All right, I don't know. If you're not having a great day now, I don't know what's going to make you have a great day. Maybe ice cream, but this is fantastic. All right, you have a great rest of the day.